In the early hours of October 26th, 2025, a brilliant fireball streaked across the skies of Thailand. It was visible from Bangkok to Chiang Mai, lighting the clouds green and gold before vanishing in silence. Moments later, a low boom rolled through the countryside. Windows rattled. The night briefly turned to day. Astronomers at the National Astronomical Research Institute of Thailand confirmed the event. A bolide, a large meteoroid burning through the upper atmosphere. It did not match the path of any known meteor shower. It came from nowhere, and it was gone in seconds. Across observatories, quiet questions began to form. Was this an isolated fragment, or part of a much larger story unfolding above us? Only months earlier, a strange visitor had entered the solar system, the interstellar comet known as 3I Atlas. It had traveled on a trajectory close to the plane of the orbiting planets, slicing directly through the asteroid belt between Mars and Jupiter. If its immense passage disturbed even a handful of those ancient stones, their orbits could shift. Some would drift harmlessly away. Others, nudged by gravity and time, could fall inward toward the sun, crossing the paths of Earth and her neighbors. A single change multiplied over millions of years could send debris wandering on random courses through the system. Perhaps the fireball over Thailand was only coincidence, or perhaps it was the first visible sign of a quiet chain reaction born from the wake of 3I Atlas. And if that is true, it may not be the last. Welcome aboard this unique flight. My name is Regina Sage Monroe, and this is Sleepy Mysteries, taking you out of this world to boldly go where no man has been before. The voice of Mission Control fades behind us.
What's the time frame on identifying and then exiting the hazard area?
Replaced by the deep hum of engines surrendering to silence. Earth falls away below, wrapped in ribbons of blue and white cloud. It is difficult to believe that everything we have ever known fits inside that shrinking sphere. Our craft climbs past the thinning atmosphere, through the troposphere, stratosphere, mesosphere, until sound itself becomes memory. Weightlessness arrives not as a rush, but as peace. The instruments steady, the stars sharpen. From this height, Earth's fragile skin glows electric with life, 90% nitrogen and oxygen, balanced by a whisper of carbon dioxide, the perfect blend that keeps oceans liquid and lungs awake. The magnetic field shimmers invisibly, deflecting cosmic radiation like a shield born of iron and motion. Our trajectory curves outward, guided by Newton's equations and 1,000 silent computers. Ahead, our first waypoint hangs in darkness, the moon. Only 3 days away at this velocity, yet it has drawn humanity's gaze for millennia. As the engines rest, inertia takes over. We glide, suspended between worlds. Behind us, Earth rotates with quiet indifference. Ahead, the ancient satellite waits, its surface carved by 4 billion years of impacts and light. We are leaving home, but not leaving history. Every voyage beyond the atmosphere begins as an echo of the first, when humankind looked up and decided that the sky was not enough. The moon has no air, no sound, no weather, yet its surface tells stories older than continents. Its diameter is just over 3,476 kilometers, 1/4 that of Earth, locked forever in synchronous rotation, so that we see only one face. Astronomers believe it was born from catastrophe, when a Mars-sized body struck the young Earth. Vaporized rock coalesced into orbit and cooled into the pale companion we know today. The evidence lies in isotopic signatures identical to Earth's mantle, proof that the moon was once part of us. The Apollo missions left behind seismometers that recorded moonquakes. When the spent stages of their rockets crashed into the surface, the vibrations echoed for nearly an hour, as if the moon rang like a bell. Scientists blamed its dry, rigid crust, but to others it hinted at hollowness, an idea never proven, yet never forgotten. Lunar orbit reveals bright highlands, dark Maria, and countless scars from meteor bombardment. The same impacts that extinguished life on Earth's surface preserved the moon's memory. For centuries, astronomers have reported flashes of light, transient lunar phenomena, brief glows on the dark plane of Aristarchus, unexplained even today. Gas venting, electrostatic dust, or something watching from within shadow. Below us, the landing sites remain untouched. 6 flags, 12 footprints, and a mirror that still bounces laser beams back to Earth. The moon is both monument and mystery, proof of where we've been and question of where we'll go.
It's one small step for man, one giant leap for mankind. It has a stark beauty all its own. It's like much of the high desert of the United States. It's different, but it's very pretty out here.
Oh, geez, that's great. Is the lighting halfway decent?
Yes, indeed. They've got the flag up now, and you can see the stars and stripes on the lunar surface. Up now, and you can see the stars and stripes on the lunar surface.
As we arc beyond lunar orbit, the far side unfolds, a landscape no human eyes had seen until 1959, when the Soviet probe Luna 3 transmitted its ghostly photographs. Crater upon crater, stacked like frozen ripples. There is no dark side, only the far side, bathed in sunlight half the time, yet hidden from Earth's radio reach. Today, robotic relays orbit above it, bridging the silence once absolute. The moon exerts a tidal pull that slows Earth's rotation by milliseconds each century. In return, Earth's gravity keeps the moon from drifting free. It is a dance of dependence, the same rhythm that stirs our tides, guides migrations, even synchronizes biological cycles in subtle ways. In the coming decades, new missions will mine lunar ice trapped in shadowed craters, water older than the sun itself. That ice may fuel rockets bound for Mars. We ignite the engines once more, leaving orbit in a shallow spiral. The moon shrinks, light falling across its craters like frost. Ahead lies a smaller, redder beacon, Mars, 225 million kilometers distant, yet already glowing faintly against the dark. We set course for the next world. The moon fades behind, still watching, still unanswered. Between the orbits of Earth and Mars lies a gulf of emptiness so vast it humbles imagination. We are now traveling at over 30 kilometers per second, fast enough to circle Earth in 40 minutes. Yet the red planet still lies, months ahead. Everything is now set to autopilot, but even the most advanced spacecraft cannot escape one truth. Human beings were not designed for the void. We carry Earth inside us. Rhythm, gravity, breath, and the need for warmth. A long-range mission must honor that truth if it is to succeed. This vessel was built with that understanding. Sleep is the most precious resource on any mission, and rest is as vital as fuel. Humanity may master propulsion, radiation shielding, and energy efficiency, but the real triumph will be this: creating a place of stillness within infinite motion. Because before we can colonize the stars, we must learn to bring home with us the void is not empty. Microscopic dust grains drift like forgotten embers, remnants of comets and collisions billions of years old. Occasionally, they strike our hull with silent sparks of plasma. The sun, though distant, dominates everything. Its solar wind flows past us at 400 kilometers per second, a river of charged particles that shapes the boundary of our entire system. Without our magnetic shielding, this invisible tide would strip electronics bare. Communication with Earth now takes minutes. Each command is delayed by distance, every word an echo from the past. Between us and Mars stretch the orbits of countless asteroids, though space remains mostly void. The largest, Ceres, lies far beyond, while smaller fragments occasionally wander close, messengers from the birth of the planets. Inside the capsule there is no up or down, only motion. We are guided by the laws of celestial mechanics, a precision so perfect it feels like fate. And ahead, painted in rust and ochre, waits a world that once may have looked a little like home. Mars rises slowly, glowing like an ember caught between fire and frost. It is half the size of Earth, yet its surface area equals the dry land of our own planet. Its thin atmosphere, mostly carbon dioxide, would suffocate us in seconds, but the evidence written in its rocks tells a story of rivers, lakes, and perhaps even oceans. Ancient river deltas carved by flowing water stretch for hundreds of kilometers. Minerals that can form only in liquid water, clays, sulfates, carbonates, lie scattered across its plains. Billions of years ago, Mars had a magnetic field strong enough to hold an atmosphere and shield its surface. Then it died. The question is why? Scientists suspect the planet's small iron core cooled too quickly, shutting down the magnetic dynamo. Solar winds then stripped the air away molecule by molecule, leaving only the ghost of an atmosphere we see today. Polar caps of frozen carbon dioxide and water still glisten at both poles. Each Martian spring, they sublimate into clouds that swirl around the planet like a sigh. Yet in those icy layers lies the record of its climate, and possibly its life. We descend into orbit. Below us, Olympus Mons rises, a volcano 3 times taller than Everest, its summit so wide that a traveler could walk across it for days without realizing they were climbing a mountain. Since the first Viking landers touched down in 1976, humanity has been searching for life on Mars. The experiments then returned ambiguous results. Hints of a chemical activity that some read as metabolism, others as reaction with oxidized soil. The debate still burns. Orbiters later discovered methane plumes rising from beneath the surface, a gas unstable in sunlight that must be replenished. On Earth, most methane comes from living systems. On Mars, no one knows. Rovers have found sedimentary layers that once rested beneath flowing water. They've measured seasonal fluctuations in gases, magnetized rocks older than the planet's last atmosphere, and organic compounds deep within craters. Some of Mars' mysteries border on haunting. Photographs show recurring dark streaks, called recurring slope lineae, that appear and vanish with the seasons. And buried beneath the southern pole, radar has revealed what may be a subsurface lake, sealed beneath kilometers of ice. For all its silence, Mars still whispers. The dust storms that once swallowed entire hemispheres now swirl faintly below. Each rover, Spirit, Opportunity, Curiosity, Perseverance, is a footprint of our persistence, marking a path for the day humanity truly arrives. As we swing past the planet's night side, sunlight flares across its horizon like dawn seen from eternity. Ahead lies the heart of our journey, the path of Atlas 3I, hidden behind the sun. We leave Mars behind, a fading ember in the black. Our course curves sunward, following a gravitational arc so delicate that a single miscalculation could end the mission in vapor. Here, space is alive with radiation. Solar particles stream past like invisible arrows, striking our hull in silent bursts. The temperature outside swings from hundreds below freezing to hundreds above within seconds. Everything fragile is sealed deep within shielding. Electronics, instruments, even thought itself. Ahead lies the region known as the inner heliosphere, where the sun's influence rules absolutely. No planet, no moon, not even light itself escapes unchanged. Our sensors mark the coordinates where Atlas 3I was last observed, an object smaller than a city, yet bright enough to challenge the stars when it first appeared. It entered the inner system from the direction of Lynx, its orbit long and cold, and according to its discoverers, its coma was dominated not by water vapor, but by carbon dioxide. That single anomaly set it apart. Most comets awaken close to the sun. Atlas 3I did so early, far beyond the frost line, as though driven by something else. We prepare for a slingshot maneuver, using the sun's gravity to bend our path and chase the comet on its outbound journey. The light ahead grows unbearable, and the engines whisper against the void. We are now falling toward the furnace. The sun fills half the viewport, a roaring sea of plasma and magnetic loops stretching millions of kilometers into space. We ride its gravity like a wave, accelerating to 50 kilometers per second. Every atom in the ship hums with heat that never touches air. Telemetry confirms the comet's trajectory, a long elliptical orbit that will eventually fling it back toward the darkness beyond Neptune. But Atlas 3I is not behaving as expected. Its coma brightened months ahead of prediction, then dimmed sharply. Spectral readings showed jets of carbon dioxide venting in bursts, too symmetrical for random activity. Some astronomers described it as pulsing, as though responding to the sun rather than merely reacting to it. For days before it reached perihelion, its closest point to the sun, the coma expanded to almost half the diameter of the sun itself, though the nucleus was barely a few kilometers across. Then, it vanished from view. Telescopes expected to track its disintegration, but fragments were never conclusively found. Some data hinted that the nucleus remained intact, fading only because its reflective gases collapsed inward. We set our sensors to maximum gain, searching for the faint echo of its tail, a chemical fingerprint adrift among solar winds. Somewhere ahead, behind the glare, the wanderer waits. Before we find Atlas 3I, we must pass the source of all light, the Sun, a sphere of hydrogen and helium 1.4 million kilometers wide, converts 600 million tons of matter into energy every second. Its surface, the photosphere, burns at about 5,800 degrees Celsius. Yet above it, the corona blazes at millions, a paradox still unexplained. Some theories point to magnetic reconnection, others to waves of plasma carrying hidden heat. But the truth is simpler and stranger. We do not yet know why the outer atmosphere is hotter than the star itself. Solar flares rise like mountains of fire, releasing energy equal to 1 billion hydrogen bombs. Coronal mass ejections sweep across space, capable of disabling satellites or blacking out entire nations. Ancient civilizations watched this same star and called it divine. Egyptians worshipped Ra, the eternal eye. Inca priests called it Inti, giver of life. To the Navajo, it was Joho, the father of dawn. Our instruments record a flare unfolding on the limb, plasma ribbons dancing 100,000 kilometers high. Even from this distance, the sensors shudder. And beyond that storm, faint but constant, lies the trace of Atlas 3I still moving outward, a ghost born of ice, fire, and mystery. The sun diminishes behind us, shrinking to a white blaze against the black. Beyond its glare, our instruments finally locate the object. Faint, fast, and colder than thought itself, Atlas 3 emerges slowly, a pale shard tumbling against eternity. Its nucleus measures perhaps 4 kilometers across, but sensors read an irregular shape, more ridge than sphere, with sharp planes reflecting starlight and pulses. Spectral analysis confirms carbon dioxide ice mixed with dust and organic compounds, the building blocks of carbon life. We approach cautiously, matching velocity. The coma that once blazed bright has collapsed into thin wisps that trail like smoke from invisible fire. Jets of gas erupt from fissures in its surface, vanishing into the void almost instantly. The rotation is uneven, a wobble suggesting recent stress. Perhaps it fractured near perihelion and reassembled, held together by frozen gases and luck. But the data is inconsistent. Thermal imaging shows warmth beneath one hemisphere, a residual glow not expected this far from the sun. Could it be chemical reaction, residual sunlight, or something we do not yet understand? The telemetry scrolls endlessly, yet the truth hides between numbers. For a moment, Atlas 3I drifts beside us, silent, indifferent, beautiful, a time capsule from the solar system's creation, and perhaps from far beyond. Comets are usually made of water, ice, rock, and frozen gases like ammonia and methane, but Atlas 3I defied that rule. When first observed in early 2020, astronomers noted that its coma was dominated by carbon dioxide, not water, a sign that it woke up unusually early, far from the sun's heat. That behavior suggested it came from a colder nursery, perhaps the Oort cloud, a sphere of icy bodies more than 1 trillion kilometers away, where sunlight is no brighter than starlight. Some scientists propose that Atlas 3I might even have originated from another solar system entirely. As we orbit the nucleus, our instruments confirm traces of silicate minerals, fragments of pre-solar dust older than the sun itself. Each particle is a fossil of the nebula that birthed our world. Under ultraviolet exposure, faint green luminescence flickers across its surface, emissions from excited carbon molecules. Seen against the darkness, the effect is spectral, not mystical, but chemistry at work in vacuum. A thin plume extends behind it, bending with the solar wind. Embedded within that tail, sensors detect ionized oxygen and magnesium, elements forged in ancient stars and recycled through cosmic time. Everything about Atlas 3I speaks of deep age and deep motion. It has traveled for millions, perhaps billions of years, carrying in its ice the memory of the galaxy itself. Yet even now, mysteries remain. During its first observation run, Atlas 3I brightened and dimmed in perfect cycles. Not random outgassing, but rhythmic pulses, repeating every 16 hours. Astronomers debated, was it rotation or resonance with sunlight? When the comet approached its closest distance to the Sun, its trajectory shifted by several hundred kilometers, a subtle change not fully explained by gravity or jets of gas. The deviation matched neither known cometary motion nor standard models of mass loss. Some theorists proposed that Atlas 3I might be a fragment of a larger parent body, perhaps the debris of an object like Oumuamua, the interstellar visitor detected in 2017. Both shared unusual shapes and light curves that hinted at artificial symmetry, though no proof ever surfaced. Others suggested that its early activation and strange path were the result of internal composition, frozen carbon dioxide trapped in crystal lattices that fractured under weak sunlight, venting jets like mechanical lungs. It is chemistry, they said, not mystery. But chemistry has never looked quite so deliberate. We adjust our orbit once more, drifting parallel to the comet's rotation. Its shadow glides across the ship, cold, precise, endless. For all the theories and data, Atlas 3I remains what it always was, a question disguised as ice. Our course bends once more, using the sun's gravity to slingshot us outward. The star that gave us warmth now burns behind, an unblinking eye whose light needs 8 minutes to reach Earth and less than 1 to strike our hull. Solar wind pressure fades as distance grows. The radiation meters fall, but never to zero. Out here, the sun still commands, though its voice grows thin. We review our data on Atlas 3I, the temperature maps, gas ratios, and magnetic readings. Each file adds clarity, but no certainty. Its carbon dioxide core, early awakening, and erratic spin remain unmatched among known comets. In a week, it will be invisible again, heading toward the outer dark. Somewhere beyond Neptune's orbit, it will fall silent for thousands of years, until gravity pulls it home once more. Its voyage is not over, only paused. As our ship turns away, sunlight flashes across the comet's fractured ridge, a final glimmer before it slips into shadow. We are now bound for the great giant of gas and storm, Jupiter, ruler of the outer planets. Our engines ignite, whispering against the void. The ship trembles as the stars begin to shift, and once more we are falling, not toward fire, but into gravity's endless sea. Even before we reach it, Jupiter announces itself. The gas giant's magnetosphere stretches more than 7 million kilometers from its surface, vast enough to engulf the sun itself if made visible. It is the 5th planet from the sun, more than 1,000 times larger than Earth, composed mostly of hydrogen and helium. No solid surface waits below those swirling clouds, only layers of pressure that crush gas into liquid metal, then into physics we barely understand. The Great Red Spot, a storm larger than Earth, has raged for at least 4 centuries. Fueled by heat rising from the planet's depths, Jupiter radiates more energy than it receives, a furnace powered by leftover creation. As we enter orbit, the view is overwhelming. Bands of cloud race in opposite directions, lightning flaring within them brighter than entire cities. Thunder here would sound like continents breaking if sound could cross this vacuum. The magnetic field screams across space, trapping radiation strong enough to fry electronics. To our instruments, it sings as static, a whisper that sometimes sounds almost alive. Jupiter has always guarded our world, drawing comets inward or casting them away. Without it, Earth might never have survived the bombardment of its youth. Every life that breathes today owes something to this distant, swirling guardian. Orbiting this giant are at least 95 known moons, a miniature solar system of ice and rock. The 4 largest, Io, Europa, Ganymede, and Callisto, were seen by Galileo in 1610, the first worlds ever revealed through a telescope. Io burns with volcanoes that erupt sulfur into space, the most geologically active body in the system. Europa, smaller and quieter, hides an ocean beneath its crust, twice the volume of all Earth's seas combined. Beneath that frozen lid, tidal forces stir heat and chemical energy, creating the conditions life requires. Ganymede, the largest moon in the solar system, generates its own magnetic field, a mystery among satellites. Callisto, ancient and cratered, bears scars unchanged for billions of years. It is a museum of the early solar system. Future missions, Europa Clipper, JUICE, will soon explore these worlds, drilling through ice to taste the salt water beneath. If life exists anywhere beyond Earth, it may be swimming right now under Europa's frozen skin. As we pass above the cloud tops, lightning webs the night side of Jupiter, like veins of living light. Our next waypoint lies far ahead, the edge of the solar system, where the sun's breath fades and the stars begin to whisper. We set course for the frontier. Jupiter fades behind us, shrinking to a banded marble wrapped in lightning. Its moons drift into alignment like ancient coins lost in shadow. Beyond this frontier, sunlight weakens to a faint gold thread, and the temperature drops below minus 150 degrees Celsius. We are now in a region once called the frost line, the point where water, methane, and ammonia can freeze solid, shaping the outer planets from vapor to ice. Here, the solar system changes character. Gas becomes ice becomes stone, and time itself seems slower. Telemetry begins to detect a new gravitational influence, Saturn. Second only to Jupiter in size, its pull extends far into space. Though twice as distant from the sun, it shines brighter than expected, a pearl wrapped in bands of gold and shadow. Our engines adjust, steering by mathematics older than flight itself. The vacuum hums. Cosmic rays rattle against the hull like faint rain. Even in silence, the stars flicker with data, each photon a message from eternity. We prepare for another slingshot, one last push before we cross into the deep. Saturn awaits, its rings calling like a frozen ocean suspended in light. Saturn is a world of illusions. Its atmosphere glows pale yellow, streaked with storms that can span half a hemisphere. But it is the rings that hold every gaze. Billions of icy fragments orbiting in perfect geometry, some as small as grains of sand, others larger than cities. The main rings stretch over 280,000 kilometers, yet are no thicker than a few dozen meters. They are composed mostly of water ice, glittering in sunlight like dust in a cathedral beam. Each fragment moves independently, colliding, reforming, balancing gravity's eternal dance. No one knows exactly how the rings formed. Some believe they are ancient, born with the planet itself. Others argue they are young, the remnants of a shattered moon destroyed less than 100 million years ago. Saturn's moon, Enceladus, adds its own mystery. From fractures near its south pole, it sprays jets of water vapor into space, creating one of the most active and beautiful phenomena in the solar system. Those plumes contain salt, ammonia, and organic molecules, ingredients of life. We skim the outer edge of the ring plane, the sunlight flickering through icy arcs. The sensors record an electromagnetic chorus, radio waves produced by the planet's magnetic field, singing through the vacuum like a haunting melody. Beyond this realm lies only darkness and the path of Atlas 3I. The sun is now a distant star, its light 1/10,000th of what it was at Earth. Solar panels fade to useless ornaments. Power comes from the steady pulse of a reactor, no larger than a suitcase. Our instruments detect the slow thinning of the solar wind, the boundary between the known and the interstellar. The region ahead is called the heliopause, where the sun's influence ends and the galaxy begins. Only 2 human-made craft have crossed it before. Voyager 1 and Voyager 2, launched in 1977, still whispering across the void. Each carries a golden record. Greetings in 55 languages, music, images of humanity. No one knows who might ever find them. They drift now in eternal night, silent witnesses to our first steps beyond the cradle. Radiation levels change. The direction of magnetic fields twists. We are leaving the solar system. Beyond this point, the Milky Way rules, a disk of stars stretching 100,000 light years, turning around a black heart we will never see. Somewhere ahead, still on its outbound arc, moves Atlas 3I. Our sensors faintly register its trace, a ghost signature against the cosmic background. We follow it into the deep. Our instruments confirm it. The magnetic field has shifted direction, particle density drops, and the hum of solar wind vanishes into static. We have crossed the heliopause, the invisible border where the sun's influence ends. Beyond this threshold, we are adrift in the interstellar medium, a thin soup of hydrogen, helium, and dust left behind by ancient stars. Each cubic centimeter holds barely a single atom, yet across such distances, even that emptiness glows faintly in radio light. Voyager 1 crossed here in August 2012, almost 121 astronomical units from Earth, more than 18 billion kilometers away. Its data revealed a world of cosmic rays and distant plasma waves, proof that space between stars is not void, but alive with energy. We listen now, tuning our receivers to the same frequencies that caught Voyager's signal. Faintly, almost imperceptibly, the galaxy hums, the combined radio breath of millions of suns. It sounds like wind, but there is no wind here, only distance. Behind us, the solar system shines as a pinprick halo, home reduced to a shimmer. Ahead lies darkness without boundary, and the path of Atlas 3I, still racing outward on its final journey. We are now travelers within the Milky Way, our home galaxy. It stretches 100,000 light-years across, a spiral of gas, dust, and roughly 400 billion stars. Our sun orbits its center once every 230 million years, one galactic year, circling an invisible core where a supermassive black hole resides. Interstellar space is not still. Cosmic rays move through it like invisible rain, high-energy particles born in distant supernovae. They strike our sensors and hull, carrying information older than the Earth itself. Here, navigation depends on starlight. We lock our instruments on pulsars, spinning neutron stars that flash with clockwork precision, using their rhythm to triangulate our position among billions of suns. Even at this speed, it would take tens of thousands of years to reach the nearest star. That star is Proxima Centauri, 4.2 light-years away, home to at least one planet, perhaps two, one lying within its habitable zone. If Atlas 3I continues on its projected path, it will pass within a few light-years of that system, sometime around the year 1 million. The comet's future and our past now run parallel, both born from stardust, both bound by gravity's patient hand. Data from our long-range scanners confirm the trail: faint dust emissions, a whisper of carbon dioxide ions scattered across interstellar darkness. It is all that remains of Atlas 3I, moving outward faster than any planet, too slow to leave the galaxy, yet too far to return. Here, sunlight is a memory. Temperatures approach absolute zero. Particles barely move. Time itself feels different, stretched and silent. Every sound we hear is generated within the ship. Every light, artificial. The galaxy around us turns slowly, its spiral arms glowing in the distance. Regions of birth and death, where stars ignite and fade. Each one may hold worlds, oceans, civilizations, but from here they are dust motes suspended in eternity. We deploy a final probe, a capsule that will follow the comet's route, transmitting data until its energy fails. Its message is simple. We were here. We looked outward. We listened. Perhaps one day another traveler will find it, or perhaps it will drift forever, another silent fragment of our species' curiosity. Either way, the trail of Atlas 3I will never truly vanish. It has become part of the galaxy itself. From this distance, the Milky Way is not a line of light, but a living river, a spiral disk viewed from within. Our sensors trace its structure: 4 major arms of gas and stars curling outward from a bright core, each arm thousands of light-years thick. The central bulge glows with old stars, ancient giants nearing their final fusion. At its heart lies Sagittarius A, a black hole with the mass of 4 million suns. Invisible, but not silent. Its gravity bends starlight into arcs. Its radiation ripples through space like the heartbeat of creation. Between those arms float vast clouds of molecular hydrogen, the nurseries of new suns. Here, dust blocks visible light, but shines in infrared, the wavelength of warmth and birth. Every second, somewhere in this galaxy, a new star ignites. Proof that even in the cold, the universe never truly sleeps. Our instruments record cosmic background radiation, the afterglow of the Big Bang, stretched into microwaves by the expansion of space itself. It whispers across every frequency, a faint echo of the moment when light first escaped darkness. Against that endless murmur, our signal home is less than a flicker, yet it carries everything we are. When the ship turns, one small light shines brighter than the rest. It is not a star, but a reflection. The sun, seen from beyond its influence, no larger than a spark in the sea of night. Through optical magnification, we can just make out the faint dot of Earth, magnitude -5, barely visible against the backdrop of infinity. From here, every war, every ocean, every heartbeat, all fit inside that single pixel. And Voyager 1 once took the same image, the pale blue dot, from 6 billion kilometers away. Carl Sagan wrote that there is no hint that help will come from elsewhere to save us from ourselves. Now, from 100 times farther, his words feel less like warning and more like truth. We transmit our data back toward that faint blue glimmer, analysis of Atlas 3I, the readings of interstellar space, and a log of this voyage. It will take nearly 20 hours for the message to reach Earth, and perhaps decades for anyone to listen. Still, the transmission goes out, a line of code across darkness, the simplest declaration a species can make. We are here. The ship now turns slowly, aligning with the direction of home. We will not travel back, not yet, but the path is marked. Navigation beacons flash, using pulsar signatures as stepping stones across the abyss. Instruments continue to gather dust samples, microscopic grains that predate our sun, forged in supernovae long vanished. Each atom within them has crossed the galaxy more times than humanity has walked its own planet. We catalog isotopes, measure ion densities, map radiation gradients. Every number we record adds one more truth to the human archive, proof that we dared to leave and learned what waited beyond. Even here, in the gulf between stars, faint glimmers cross our path, cosmic rays striking detectors, fragments of distant stories, written in light. They remind us that the universe is not empty, merely vast beyond measure. Somewhere ahead, Atlas 3I continues its silent arc, an emissary from the past, carrying secrets older than our sun, destined to drift among alien suns for eternity. We follow only long enough to see where its path leads, to the next dawn of the Milky Way. We rise slowly out of the galactic plane, guided by thrusters that correct our orbit by microns each second. From this perspective, the Milky Way stretches below like a luminous whirlpool, its arms glowing blue-white where new stars form, red where they die. Computer mapping converts visible data to structure, a barred spiral roughly 100,000 light-years across, wrapped in a halo of dark matter, 10 times its visible mass. No telescope has ever seen that halo, yet its gravity holds the galaxy together. Without it, the stars would scatter like sparks from a dying flame. The void above is not truly empty. Rogue planets drift here, worlds without suns, cast out from their systems by gravity's violence. Astronomers estimate there may be more of these wanderers than there are stars. Radiation monitors detect bursts from distant gamma-ray sources, supernovae collapsing into neutron stars, black holes feeding on their companions. The light that reaches us now began its journey millions of years before humans evolved. We are witnessing ghosts of energy long extinguished. Below, the spiral arms of our galaxy turn with the slow grace of eternity. Every rotation takes 200 million years, and we, for the first time, are watching it from outside. Among 400 billion stars, the odds of solitude seem impossible. Yet as of now, humanity has detected no confirmed sign of intelligent life. Radio surveys from Arecibo to the Allen Array have scanned millions of frequencies, finding only the quiet hiss of cosmic background. Still, the search continues. Astronomers study exoplanets orbiting nearby suns, measuring the thin shadows they cast during transit. More than 5,000 have been catalogued, and dozens lie within their star's habitable zone, where liquid water could exist. The Kepler Space Telescope revealed that roughly 1 in 5 sun-like stars may host such worlds. That means billions of possible Earths, and perhaps billions of versions of us, staring upward, asking the same question. Closer to home, probes continue scanning the icy moons of Jupiter and Saturn, searching for subsurface oceans. Elsewhere, the James Webb Space Telescope has begun analyzing atmospheres of distant planets, looking for biosignatures, oxygen, methane, and water vapor together. It has already found strange worlds of glass, carbon, and iron rain. Statistically, life should be everywhere. The silence is what remains unexplained. Physicist Enrico Fermi once asked, "Where is everybody?" It became the most haunting question in astronomy. If the universe is old, vast, and filled with potential worlds, why have we heard nothing? Some believe civilizations rise and fall before they can master interstellar travel. Others suggest they choose silence, watching, waiting, studying younger species from afar. There are even theories that we simply do not yet recognize the signals, that alien communication may not use sound or radio at all, but light, gravity, or quantum entanglement. Mathematically, there should be tens of millions of technological civilizations in our galaxy alone, yet every telescope returns the same quiet, a silence so complete it feels deliberate. Perhaps the answer is simple. We are early. The universe is still young, only 13.8 billion years old, and most stars that will ever shine are yet to be born. Maybe we are the first wave, destined to light the dark for others to follow. If you are enjoying traveling with me today, be sure to click the subscribe button so you never miss a sleepy mystery. The ship drifts in stillness, surrounded by a silence not empty, but expectant. Somewhere ahead, Atlas 3I continues its lonely course, proof that motion endures even when sound does not. For the first time since launch, our navigation computer displays a choice. Continue outward into the galactic halo, or begin the return arc toward the inner system. In reality, neither is simple. At our current speed, even braking requires months of calculation, years of drift. The decision mirrors humanity's own. Each generation must choose whether to stay or explore, to rebuild or to reach beyond what's known. And yet we always move forward. Projects already exist that look to the stars. The Breakthrough Starshot Initiative plans to send microscopic probes to Alpha Centauri using lasers, pushing them to 20% the speed of light. If successful, they could reach the nearest star system within a human lifetime. Others dream of generation ships, vast, self-sustaining arcs carrying thousands of lives, slow but enduring. They would turn space into home, not frontier. Every discovery we've made, from Voyager to 3I Atlas, has taught us that the universe is not hostile, only indifferent, and indifference can be changed by curiosity. Where curiosity leads, civilization follows. So perhaps this journey is not just observation, but rehearsal. All data gathered so far is being archived into the ship's crystalline storage, light etched into glass, resistant to radiation and time. Each sequence of numbers encodes temperature, chemical composition, magnetic flux, and navigation logs. If found one day by another traveler, it will serve as proof that we reached this far. Humanity's oldest legacy has always been light. From the first fire to the stars we now map and measure. Every invention of communication, from cave paint to code, was an attempt to be remembered. We are not eternal beings, but we make eternal messages. Even now, Earth's radio signals are spreading outward, a sphere 60 light-years wide, carrying the sounds of laughter, wars, languages, and songs. Long after the planet itself fades, those signals will continue. And if they are ever intercepted, they will tell the same story all civilizations share. We were here. We looked upward. We asked why. The ship's data beacon activates, syncing its trajectory with that of Atlas 3I. 2 wanderers, one human-made, one born of cosmic ice, now follow parallel paths into the dark. Sensors detect a faint rhythmic pulse ahead, not natural but patterned. For a heartbeat, it feels like contact. The analysis reveals the truth. It is our own transmission, looping through the interstellar medium, reflected by distant plasma clouds, an echo of ourselves returning from the deep. We realign toward the sun's coordinates. At this range, its light takes more than a full day to reach us. Yet even a star that small in the window feels like gravity in visual form, a reason to return. Autopilot initiates the first braking burn. A slow arc forms on our navigation display, a curve that will carry us, over decades, back toward the inner system. The journey home is begun. Out here there are no borders, no maps, only trajectories. Every ship ever launched, every probe, every radio signal has become part of a single spiral, humanity reaching outward, circling back, learning, trying again. The stars ahead remain countless, patient, and bright. The stars behind feel somehow warmer. We are between both, belonging to neither, and that perhaps is what exploration truly means. The engines burn for precisely 9 minutes, a soft push against the dark. It will take decades for this turn to bring us back to the sun. Yet even now, the course is set. Space requires patience. It rewards no haste. As we decelerate, dust streams past in glowing trails, fragments of the interstellar medium stirred by our motion. The sensors hum with new readings. Cosmic rays, charged hydrogen, faint X-ray emissions from distant binaries. Each particle tells a story of a star's death somewhere long ago. Behind us, Atlas 3I continues outward, its orbit carrying it beyond the heliosphere, where no sunlight will ever reach. It will drift until captured by another gravity, perhaps circling a newborn star billions of years from now. By then, even its name will be forgotten, yet its atoms will remain, becoming part of new worlds. We record the last telemetry before its signal fades, the final whisper of carbon dioxide and dust dissolving into the void. Then silence, not an end, just distance. Every mission begins with curiosity, but it ends with gratitude, not for what was found, but for having looked at all. Weeks pass. The sun, once a pin of light, begins to brighten slightly, proof that our orbit is bending homeward. Even across billions of kilometers, its warmth feels like memory. Telemetry analysis fills the ship. From Atlas 3I, we confirm the chemistry of ancient ices, carbon dioxide dominance, organic traces, presolar grains. From deep space, we mapped plasma waves, cosmic dust densities, and magnetic field inversions never measured before. These are not romantic discoveries, but real ones. Numbers, equations, spectra, data that will inform 1,000 future missions. Each bite of knowledge brings the human story one page further from ignorance. We send another transmission toward Earth, this one compressed for clarity. It carries not conclusions, only questions refined into data. And that may be the truest form of science, to leave fewer mysteries behind than we found. Outside, a micrometeor passes close enough to shimmer like a spark. Even here, chance remains alive. The solar wind returns, faint but familiar. Instruments detect charged particles accelerating outward from the sun. The first breath of our own system greeting us. We have crossed back inside the heliopause. Ahead lie the same worlds we once passed. Jupiter's storms, Mars' rusted plains, the silent moon keeping its vigil. Each will appear again, changed only by time and perspective. The ship's systems recalibrate for the inner environment. Radiation drops, sunlight sharpens, the panels glow with power not felt in years. Our sensors begin picking up faint radio from Earth, static, then fragments of voice, then music. It is an old recording, likely broadcast decades ago, a song from a world that still spins in blue and white. The melody echoes softly through the cabin, crossing all the distance we dared to travel. We are not there yet, but the signal is proof enough. We were never truly alone. The light grows stronger each day. Our sensors flare with the heat of radiation, magnetic flux, and solar wind. It is the same light that once pushed us outward, now pulling us home. Through the viewing array, the inner planets begin to emerge. Faint points of reflected sunlight scattered against the black. Venus glows brightest, wrapped in sulfuric haze. Earth follows, its thin halo of atmosphere scattering blue. For the first time in decades, we detect the electromagnetic heartbeat of civilization. Navigation satellites, radar pulses, carrier waves. Humanity's technological aura, invisible from afar, now paints the darkness with rhythm. All that data, all that sound, all that striving, it began with the same impulse that sent us into the void. Curiosity, the desire to know what lies beyond the horizon. The navigation computer confirms orbital insertion parameters. We will pass near the moon, looping once before re-entry. That same pale guardian that watched over our launch now greets our return. Its craters, unchanged, shimmer in the sunlight, a reminder that time moves differently for stone and sky. Every circuit hums with familiar gravity again. The long silence is behind us, but the stars remain ahead. Transmission log, final entry. We followed the path of Atlas 3I, measured its fragments, and mapped the silence beyond the sun. We crossed the heliopause, recorded the hum of the galaxy, and returned to the cradle that made us. There were no messages waiting in the dark, no voices from other worlds, no answers written in starlight. And yet we found meaning, not in what we discovered, but in the act of searching. Every generation will go further. New ships will rise faster and smarter, carrying the same question in different languages. what else is out there. The ship's sensors catch a final reflection, sunlight glancing off a distant trail of ice, fading toward the outer dark. It might be another comet. It might even be Atlas 3I, continuing its endless flight beyond our reach. As Earth grows larger in the viewport, one thought endures. If the stars are our ancestors, then we are their memory, traveling, learning, dreaming still. This is Regina Sage Monroe, closing transmission for Sleepy Mysteries. Subscribe for more factual mysteries of science and space, narrated by Regina Sage Monroe, where every story begins with truth and ends among the stars.